Math 2, Unit 3, Review Worksheet, Even Numbers 2 through 40. Number 2, measure of angle R and the measure of angle W are both 35. So let's write that information in, 35 degrees. Measure of angle V and the measure of angle S are both 72 degrees. Line segment RT is congruent to line segment W or UW. Alright, so we know these two triangles are congruent by angle, angle, side equal to or congruent to angle, angle, side. What is the length of VU? Well, we can see that VU is right here, and so if we think of angle, angle, side or triangle, let's go SRT is congruent to triangle SRT is congruent to VWU, and we know that by angle, angle, side. Well, we can see that UV right here matches up with ST, so that means that UV or the measure, or not, excuse me, UV equals 5. When there's no line above it, means the length of UV equals 5. Okay, moving on to number 4. Name all the corresponding congruent parts given RST is congruent to FGE. So that's pretty easy. We just start here with line segment RS is congruent to line segment FE. Then we can say line segment ST is congruent to EG. And finally we can say line segment TR is congruent to line segment GF. And the angles, angle R is congruent to angle F, angle S is congruent to angle E, and angle T is congruent to angle G. Alright, moving on to number 6. In the diagram, what is the measure of angle DCN? DCN is right here. Okay, so we're looking for this guy. Alright, by the definition of congruence, what additional information is needed to know that triangle NDC is congruent to triangle NSR? Alright, so we know that they're giving us angle D is congruent to angle S. We know that CN is congruent to RN. So the one other thing we'd need to know is that vertical angles are congruent. So we can say the two triangles are congruent by angle, angle, side. I should say angle, angle, side is congruent to angle, angle, side. So what we know is, since these two angles are congruent and these two angles, if angle R is 75, then we know angle C, the measure of angle C, is equal to 75. But first, before we can actually say that, we have to say, yes, we know that triangle NDC is congruent to angle S, or triangle NSR, by angle, angle, side postulate. Okay, moving on to number 8. Alright, where are we? Number 8, here we go. Which postulate or theorem can be used to determine the measure of angle R given that the measure of angle O is congruent to the measure of angle L? So again, we know these two guys are congruent, and of course we always know that vertical angles are congruent, and you can see that line segment RL is congruent to line segment NO. So what postulate theorem to prove that the triangles are congruent? Well, we can use angle, angle, side is congruent to angle, angle, side. And now that we know that the two triangles are congruent, we can say that angle R is congruent to angle N. Okay, so we know these two guys are congruent. And now that we know that, we can say these two guys are congruent through CPCTC. Corresponding parts of congruent triangles are congruent. And now we know that their two measures are congruent. Okay, moving on to 10 through 18. This section is going to be on the test for sure. On the test, you'll have to name the congruency postulates, but not necessarily state the congruency statement, but we'll do that here. All right, we got some options here since all four of these guys are congruent, so we can say this through side, angle, side, and we actually have some choice here. So we'll say triangle RSQ is congruent to triangle. We can actually, since we went this way, we could go this way or this way, so I'll go TSU. All right, over here we know these two triangles are congruent by side, side, side. And we know that we just picked the first one, so I'll go triangle MNP. Now we got to be a little more careful with the second. So we went one line, two lines, so we'll go PQM. All right, number 14. So we know these two triangles are congruent. Since they're right triangles, we can say by hypotenuse leg. We can see that the two hypotenuses are congruent and they share one of their legs. And so we can say triangle, let's go KMJ, is congruent to KML. Triangle KML. Okay, moving on to number 16. All right, this one you should be pretty good at. This is angle side angle is congruent to angle side angle. And let's see here, we'll go triangle, we're going to go one line, no lines, two lines. So I'll say triangle PSR is congruent to one line, no line, two lines, or triangle RQP. All right, moving over here. So you see the right triangles, you might think, oh, this is going to be hypotenuse leg, but we don't know that their hypotenuse are congruent. So we can say the two triangles are congruent by side, angle, side, side, angle, side. And so we will say triangle, let's go ABC, is congruent to, well, we went no line, one line, and then two lines, so we'll go, see, if we went this way, we'd be wrong. So we'll go here, EFD. No lines, one line, two lines, EFD. Triangle, EFD. Okay, moving on to our first proof with number 20. Let's see what we got here. Number 20. Okay, first things first, given, given, and then we just write given here. And let's see, we know that the given information is already put up here. We know they're parallel, and we know that angle B and angle D are congruent. And then it says the measure of angle BAC is congruent to the measure of angle ACD. Okay, and we know that these two guys are congruent. Remember your parallel line theorems. Okay, that's alternate interior angle theorem. Okay, when lines are parallel and cut by a transversal, alternate interior angles are congruent. All right, reflexive property, that should be a help. Line segment AC is congruent to line segment AC. They share that side. So now we can say that triangle ACB is congruent to triangle CAD by angle, angle, side. Okay, and now that we've proven the two triangles are congruent, we can say that the corresponding parts are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. All right, moving on to number 22. Number 22, name a common angle for triangle TPQ and triangle RPQ. Notice they both share P, don't they? In fact, they both share angle P. So we can say anything with a P as the vertex right there, D. All right, moving on to 24. Name a pair of overlapping congruent triangles. State whether they are congruent by side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. So if we take triangle ADC and triangle BCD, okay, ADC and BCD, we can see that they share this side, okay? And we also know from the given that AD is congruent to BC, and we know that ADC is congruent to BCD, so we can say that triangle DAC is congruent to triangle CBD by side angle side postulate. Okay, moving on. All right, a transformation. 3 points each for this. One for the pre-image, which we will graph right now. Graph a triangle whose vertices have the coordinates of A is at 3, -1, so 1, 2, 3, -1. B is at 5, 1, 2, 3, 4, 5, -1. And C is at 4, 1, 2, 3, 4, -3, 1, 2, 3. I'm going to double check those. So, oh, see, I went -3, -1, and we want to be at +3, -1. Okay, so let's double check again. 3, -1, that's A. 5, -1, that's B. And 4, -3, 1, 2, 3, 4, -1, 2, 3. Always a good idea to check your points just because of what you saw me do. Make a simple little mistake. You got to fix that. Double check. Always double check. Okay, they want us to reflect it over the y-axis and name it triangle A prime B prime C prime. So here's the y-axis. The y-axis is vertical, so we're simply moving this thing horizontally. So A to the y-axis is 3, so this actually will turn out to be A prime. B is 5 to the y-axis, so this will end up being B prime. And C is 1, 2, 3, 4, 1, 2, 3, 4. You remember I said the rule when we reflect over the y-axis, the y values stay the same, but the x values become the opposite. The x value of A is 3, A prime is -3. The x value of B is 5, B prime -5, and the x value of C is 4, and the x value of C prime is -4. Our y value stayed the same. Number 28. All right, so here write a congruency statement for the two figures in each coordinate grid, then write a congruency transformation that maps the one figure to the other. So for these, I think it's a good idea to use your patty paper. So we're going mapping ABC to DEF. So I'm going to go ahead, and you should be careful with this. We're going to always mark the origin and then mark A, B, and C. And we're going to see, what do we have to do? This looks like maybe a rotation, so let's try a rotation. Oh, I don't know. Let's try counterclockwise here, if I can get this thing to rotate. 90 degrees. I don't know if that's going to help us. Let's try 180. Not too good. So maybe we need to try a reflection. Let's try a reflection maybe over the x-axis. Okay. Oh, now that's looking pretty good. They look pretty similar. So now if I slide it, it looks like maybe 1, 2, 3, 4, 5. There it is. So a reflection over the x-axis and then a transformation or a translation of 5 to the right. All right, so you can see now, if I put that over there, it looks like ABC becomes DEF. So that works. Okay. So let's figure out what we did. Let's see. We reflected over the x-axis and translated, I believe it was 5 to the right. Let's just double check my 5 to the right. 1, 2, 3, 4, 5. Yes, 5 to the right. Now we would write this like this. The rule is actually a reflection. Remember, in reflection over the x-axis, the x stays the same, but the y becomes the opposite. But then if we're going to translate it 5 to the right, it's x plus 5 and negative y. So that would be the rule. The simple rule would be xy becomes x plus 5 negative y, or opposite of y. Okay, number 30. Let's check this guy out. All right, let's use our patty paper and see what we're going to do here. So again, we're going ABC. All right, so let's see what we got to do here. Well, I don't think it's a rotation, but maybe a reflection again. Let's see what happens here when we reflect this guy. Alright, that looks pretty good. And then maybe up 1 and to the right 1, 2, 3. Alright, so again, looks like I reflected over the x-axis again. And then translated it. I'm pretty sure that was 3 to the right and up 1. And the rule, xy, remember this, we went over the x-axis this time, so x stays the same, y becomes the opposite, but then we translated it 3 to the right, so that's x plus 3 and negative y plus 1 to move it up 1. So the basic would be xy becomes x plus 3 negative y plus 1. And there's your rule. Okay, moving on to number 32. Solve for x and y. Alright, well I can see that this is an isosceles triangle, which means my base angles are congruent. So I can see that x equals 50. And since 50 and 50, y must equal 80. Moving on to 34. Remember, okay, the exterior angle equals the sum of these two angles. Alright? So that means that x plus y equals 115. But that's not enough to help us yet. Okay? We also know that this is an isosceles triangle, so if this is x, this other base angle is x. This is isosceles, so this is the base, which means these are base angles. So now we can use these two guys. We know they have to be supplementary. So x plus 115 has got to equal 180. So let's go down here. X plus 115 equals 180. So if we subtract 115 from both sides, we find out that x equals 65 degrees. So we found x. Now we just got to find y. We plug it in. 65 plus y equals 115. Subtract 65 from both sides, and we find out that y equals 50. And 50 plus 65 equals 180, so it worked out. All right. Number 36. Again, this is another isosceles triangle. I know this is my base because my base angles are congruent, which means this side is congruent to that side, which means I can set up the equation 7x minus 4 equals 5x plus 2. Subtract 5x from this side, it goes away. Subtract 5x from this side, I get 2x. Add 4 to this side, it goes away. Add 4 to this side, and I end up with 6. Divide both sides by 2, and I get x equals 3. Okay, and there's no y here to solve for, so I'm done. Okay, moving on to 38. Find the value of x. All right, we'll see. We got these two angles. We got to figure out the last one. Well, 72 plus 36 is 108, which means this angle's got to be 72, which tells me that these two guys are my base angles. That is my base, which means these two are the congruent sides of an isosceles triangle, which means 4x minus 2 equals 3x plus 5. Again, subtract 3x from both sides, leaving x here. Add 2 to both sides, and we get x equals 7. Last one. All right, we got 58, and we got 64. We'll add those together, and we get 122. Subtract 122 from 180, and we get 58. So we know this angle is 58 degrees because I have to add up to 180, which means this is my base. Base angles are congruent, which means these two guys are the congruent sides of an isosceles triangle. So we can set up our last equation as 4x plus 12 equals 3x plus 5. We'll subtract 3x from both sides, and we get x. Subtract 12 from both sides, and we get negative 7. There it is.